and have some fun with a roller coaster after I give you some background information. So today we're going to talk about energy. And does anybody know what energy is? Actually, that's great. Okay, so if I could have you guys get on to Socrative, please. And this is the ID for it. I lied. We're not going to do it. We can't do it because it's on my iPad. So scratch that idea. Okay, so does anybody know like a relative idea of what energy is, like, or an example of energy?
I know it's measured in joules. Is that correct?
Yes.
Yes. Okay.
Anybody else?
I know it's usually like kinetic or potential.
Yes. So what do you need? Well, so like, you need energy to do anything. You need energy to sit where you're sitting right now. You need energy to write. You need energy to look at me. You need energy to do everything. So energy, we're just going to go with the basic definition today, and that is the ability to do work. And as she said, energy, she said that it can be potential or kinetic. She's right. Energy can be many different forms. The two forms that we're going to talk about today are potential energy and kinetic energy, and we're going to worry about the other forms at another day. We're just going to start with the basics today. I'll get fun. So along with this is energy cannot be created or destroyed. It can only be transformed. That's something very important for you to remember for the activity later. All right, so does anybody know what potential energy is? Yeah, so it's the energy that's possessed by an object by virtue of its position relative to other objects. So I'm going to talk about it in relation to a roller coaster because that activity we're going to do later talks about roller coasters. So I'm going to kind of use this. So I'm going to use my hand. Let me see if I can do this. Okay. So do you think that my hand up here has more potential energy or my hand here has more potential energy?
Left hand.
Should be yes. This is yes. Everything about this second. Okay. So yeah. So the higher something is, the more potential energy it is. So the definition was energy possessed by an object by virtue of its position relative to others. So the position is the ground. So my left hand is higher than my right hand relative to the ground, so it has more potential energy. So yes. So the next energy that we're going to talk about is kinetic energy. Does anybody know what kinetic energy is?
Like energy that's like being used.
I'll give you an
Can you
example.
like do work?
Yeah, so it's kind of like that, but I'm going to give it a more broader definition. It's the energy of motion. So anytime something is moving, you're using kinetic energy. So again, if I put my hand, it's going to kind of work. It might confuse you. Let me know if I'm going to confuse you when I say this. Put my hand up here. Will this have more potential energy, or more kinetic energy, or less potential energy? Sorry. Will this have more kinetic energy or less kinetic energy than my hand down here?
Wouldn't they have equal because gravity acts the same on all things?
Well, so for the basics of what we're doing, we'll build onto that at a later date. But for right now, I want you to know that since my left hand up here has more potential energy, it's going to have less kinetic energy. And my hand down here, since it has more or less potential energy, it's going to have more kinetic energy. Does that make sense? Yes or not really?
Oh, to make them like even out, I guess.
Yes.
They're gonna end up
Because-
at the same spot.
So I'm doing that like a roller coaster.
Okay.
So my one hand is sitting up here, the
Okay.
other hand is down here. So my hand up here has more potential to do something than my hand down here. Does that make sense?
Yes.
Okay.
That makes sense.
So the total energy of a system for today's definition, today's basics, is just going to be the kinetic energy plus the potential energy. Now on the activity that we do later today, you're going to do a little bit of graphing, and it's going to have heat on there too. Heat is also a form of energy. You're going to draw it on the graph, but we're not going to worry about it today. So, like I said before, along with kinetic and potential energy, there are other forms of energy as well, such as heat and thermal energy, but we're only going to worry about the kinetic energy and the potential energy today. Alright, so has anybody used a FET simulation before? No? No? Okay, they're really fun to do. So, we are going to use a FET simulation of a roller coaster to look at kinetic energy and potential energy and to figure out what affects the changes in potential energy and kinetic energy. So, I'm gonna kind of have you guys work in one big group to do this activity. This is the link. Hold it up. If you could go to this website, you can do it on either your iPad or your computer. And let me know when you get that pulled up, and I'll talk a little bit while you're getting it up. So we're gonna go to this, and we're gonna start with the simplest one where it already gives you the roller coaster made, so that you can look at a few different things. If you guys, can you see it?
Sort of, yes.
If you guys want to work in a
Is this skate pork?
if you want to work in one big group,
I'm gonna go ahead and guess.
to maybe make it easier, since does anybody in here have a physics background, or has anyone taken any physics classes? Probably not since high school. Yeah, okay. So if you guys want to, for the sake of like just remembering things, if you want to work together in a big group, or a few of you, or if you want to work by yourself, that's totally fine too. Go. I'll walk around the room, make sure everyone's got the right thing. Let's see.
Yeah.
Park.
Yeah, so it's energy dash skate dash
Skate
park
park slide.
dash basic. It's a good thing I wrote this on here, because
Yeah.
I did not realize we didn't have a whiteboard in here.
Did it work?
Hopefully it comes up. It'll be like a,
When I typed that full thing in, it said that there was nothing available.
okay, so then go to, no, you're on the right site still.
You got this?
Yeah, I got you got it.
Phase
Just gotta click
simulations.
when it loads.
Oh, do I?
And
Yeah,
then
it'll
go
be a
to
second.
Oh, okay.
Physics,
Yep, right there. Just
I think I've done this actually.
yeah,
before.
now that I
and then go all the way down, and
Remember.
it should be,
deep in the memories.
Yes.
it should be,
It's like freshman year
here,
high
go
school.
energy
Yeah.
skate park basics,
Be like, ooh.
and then just download it, or just click the play button. It should work. Does everyone else have it up? Alright, and then just click that. You gotta make sure when you get to that first website that you just click the intro tab, because that's gonna be the basic one. Once you figure out the things that I would like you to figure out using this activity that I'm going to hand out, then I will let you, time permitting, design your own roller coaster and mess with that, which is gonna be cool. So, if you guys wanna work in groups for this, or if you get confused at any point or have questions, please let me know, because the wording can be a little confusing on this. So, we'll work together on question 1. So everyone is at this right here where you have the basic ramp with the skateboarder.
Are we doing playground or are we doing?
Nope, you're gonna go to the intro.
we're doing
The
intro.
playground is the one you're gonna do later when you can make your own roller coaster.
Okay.
We're just gonna figure out the basics first. Okay, so question 1 says, turn on the bar graph. So on the right hand side, there's this box of things that you can turn on. You're gonna want to turn on the bar graph and the speed indicator. So it should just say bar graph and speed. Just make sure those 2 are checked. And if you want, you can check mark the grid too. The grid just makes it like graph paper in the background, so you can like see how high you're putting the little skater. So the first thing you're gonna do is put your little skater dude on the top right of the ramp. And it shouldn't go down, and if it does, just hit the pause button. So hit the pause button and then put it back up again.
Is he just supposed to sit there?
Yep, it's just supposed to sit there.
Oh.
So if you hit the pause button, and then move him to the top, he'll stay still.
Cool.
Oh.
Yep.
Pause. There
You got it?
Come on, get over there. Like that?
Yep.
Oh, okay, there we go. Nice.
Might need a little bit slow because it's one of those HTML things. So you got it over here?
No. I was just looking at
You guys want to like move over to see theirs, I guess? Okay, so what you're gonna do is you're gonna draw. So when it says top right of the ramp right here, you're gonna draw the bar graph that you see. So you're gonna draw the kinetic bar and the potential bar and the thermal one. So I guess it said thermal and not heat. But remember, we're not gonna worry about the thermal part today. And when you got that sketched, you can move on to the next one where you put the skater at the bottom of the ramp. And then go on to the third one where the skater's at the top left of the ramp. And then if you guys wanna let me know when you're all done. You just gotta put the little skater at the bottom of the ramp.
Already did.
Should've known that was gonna happen. Guess I didn't play around with the simulation as much. So you wanna check the bar graph and then the speed one to get the graph. So then that graph on the left side is what we'll be sketching. So what you'll find is that, actually I shouldn't say what you find, what did you find? Can anybody tell me what they see in the graphs?
Potential energy equals total energy whenever he's at the top.
Because the skater has no kinetic energy, no motion, yep. So what are you seeing between the top right and the top left? Is it different? Oh, it should be the same because the skater's at the top of the ramp in both of them. What did you see when you put the skater at the bottom of the ramp? No energy. Yeah. And now if you would have clicked the play button and started him at the top and made him go down, you would have seen, you're gonna see the bar graphs go up and down and up and down. So, question 2 says discuss the energy changes that you see in the bar graphs, which we just talked about. Which energy bar stayed constant the whole time? You said it.
Oh, total.
What energy was at a maximum when the skater was at the top of the pipe?
Potential.
Yep. Okay, so now to answer the next question, what you're gonna wanna do is probably put the skater at the top of it again, just so you can get a sense, and then click the play button, and watch what happens when they get to the bottom of the ramp. So look at the bar graphs, what do you guys see?
Kinetic goes up and goes down.
Yep, so for question 2, 3, which energy was at a maximum when the skater was at the bottom of the pipe? It's the kinetic energy, right? Alright, so now you're gonna turn on the speed dial and discuss the skater's speed at the top and the bottom of the pipe. So at the top of the pipe, what's the skater's speed?
Like 0 maybe?
Yep, and what is it? I know it doesn't have the numbers, but what can you tell about the speed at the bottom of the pipe?
It increases.
Yes. I wish it had the numbers so you could see actually like how much it's increasing, but that's what we got. So, the third question is what you guys are gonna get to mess around with. So, if you go to playground mode, you will be able to build your own roller coaster by taking the 3, is it red?
Yeah.
Okay, the 3 red dots at the bottom are the tracks. So you have 3 sets of tracks that you can make, you can make whatever you want. So take those tracks and make sure that you have your, speed and your bar graph on. Cause you're not just gonna play around with it though. Well, I guess you are.
It's like, that's
You're gonna
creepy.
see how does the
Interesting,
energy,
Jason.
how do the different energies change when you put on friction? How do they change when you increase or decrease the mass? So, does anybody know what friction is?
It's the force pushing back.
Yeah, so in a skate park sense with a skater, it's gonna be what slows the skater down. So if you want, I would turn the friction to none, and we'll discuss friction tomorrow. Because friction is a whole other thing that messes with the energy. I just want you guys to get the basics of it today so that we can build on at a later date. So, I like that one. So you gotta build, start your skater, and keep an eye out, keep little notes about what happens when you, keep notes on what happens when you change the position of the skater, when you change the mass of the skater, and when you change, just keep track of what happens when you change the position and the mass, and then also look at the speed. So the 3 things I want you to look at when you're building your playground or when you're building your skate park is the position, the speed, and the mass. How do those things affect the kinetic and the potential energy, and even the total energy? So if you guys have 3 sets of those red bars that you got,
No.
Upside down.
yeah, there is also a way that you can put them upside down like you found out, and it's the same thing. But make sure you have your bar graph and your speed on, because I want you looking at what happens when you change the mass, the position, and what happens to the speed too. Oh, and also, you want to change your friction off because that will affect everything. So your skater should keep going as long as the friction is turned off, because there's nothing stopping it. I like your guys' roller coasters that you're designing. They're pretty cool.
You just like
Be some engineers someday.
That's fun.
Yeah, make sure you have your friction off, and then do you have your friction off, AJ?
Yeah.
Because the friction will affect things. I'm gonna do it.
17 minutes.
Alright, so
I erased.
I'm gonna wrap it up quick. This is always available, plus there's a lot of other fest simulations that you can do if you are ever interested or bored. This is what I did on my day off. So, what are you guys noticing about the position, like when you change the position, what happens to the kinetic and potential energy? So, back to what I said in the beginning.
Skater, you said?
Yeah, so if we're putting the skater all the way at the top, and then all the way at the bottom, how does the potential and kinetic energy change? So if you
As
look,
the skater gets like closer to the ground, then the potential energy like decreases.
Yep.
And kinetic energy increases.
yes, and what stays the same again?
The total energy.
Yes. Alright, so what have you noticed about the speed? How does the speed change things? So the more speed, the higher the what energy?
Kinetic energy.
Yes.
Is it kinetic?
Good. Yes, it's the kinetic energy. Because remember, the kinetic energy is the energy of motion. Just remember me making a fool of myself running.
Yeah.
So the higher the speed, the higher the potential, or the higher the kinetic energy. Right, so what are you noticing when you mess with the mass?
They go like.
So
there's
if
more
you make
energy.
your skater really, really small, what happens to the kinetic and potential energy?
It's less. The total energy will be less.
And what happens if you make them really small? Yeah.
It's less.
So think about it as a mouse coming at you or an elephant. What would you rather have coming at you?
Probably a mouse. I would
Yes,
say.
definitely, because it has less energy, it's not gonna hurt you. But if an elephant's running at you head on, you're definitely gonna get trampled. So, that's that last question on that handout I gave you. Just, if you wanna jot down some notes, and you'll be able to use that at a later date when we add on about the different kinds of energies. Any questions? Awesome.